Okay. If we have these 2 points, there's a straight line through those points, right? So mark the straight line like so, straighter than usual. Okay? And I could also put arrows here and here to show that it keeps going, although that's not always necessary, and you won't always see it. It's kind of implicit. Okay? Okay, so do we know how to find the slope of this line? I showed you how to do the fundamental triangle. We've done the fundamental triangle. So we just haven't done the slope or the equation of this line. So if you know the fundamental triangle, I'll do one here. But if you know the fundamental triangle, the rest is very easy. Okay, so here's your fundamental triangle. One side is parallel to the x-axis. The other side is parallel to the y-axis. One is horizontal, in other words, and one is vertical. It doesn't matter if you do it down here or up here, right? I could equally well have drawn the thing down here, but it's easier to label up here. Got more room above it. Of course, then I've got this in the way. But no matter what you do, you're going to get something in the way. Okay. So you get the run. And also you draw arrows to show how you're moving from this point to this point. So you get from here to here if you go this way, and you get from here to here if you just shortcut across the hypotenuse, right? So you want those arrows. Okay? So the rise is 0 minus 4 equals negative 4. So the slope is rise divided by run is negative 4 over 7. And I make a convention that we put that slope in a box right here, because if you've got this picture, you always know to look for the slope here, not in half a page of calculations where you got to search for it. You always know where to look for the slope. It's here. And this picture tells you everything you need to know about the slope of this graph. Okay? So you don't need a bunch of algebra sitting over there, a bunch of arithmetic. Okay? You've got a picture. So that's easy. Okay, well, now the equation of the line is y equals mx plus b. Now, one of these things, m or b, is the slope, and the other is the y-intercept. Now, I want everybody to just raise their hand or finger or nod vigorously. Is m the slope or the y-intercept? Tell me if you think m is the slope. Okay? Some of you got your hand up a little late, so I'm not sure if you knew or were seeing everybody else raise their hand. You get a chain reaction there, but I think everybody pretty much knows this. It's familiar stuff. Yeah. Okay, that's a slope, that's a y-intercept, right? So I don't have to write out a bunch of words. I just say, okay, this is the slope, this is the y-intercept. Well, then the slope is negative 4/7. And the y-intercept is 4. There are two ways you can write the y-intercept. It's the 0.04, or it's just the value of y on that point, because you know the zero is there, right? When you're doing the equation, you don't want to put an ordered pair in for the y-intercept, right? You just put the number. negative 4/7 x plus 4. Now, an exercise I did just the other day with the support course is I asked people to estimate the coordinates of a point on this line. So given that this coordinate here is 7 and this coordinate is 4, what do you think are the coordinates of this point? Well, the x-coordinate, you just draw a vertical projection line up to here, and here's your x-coordinate, right? And then you draw a horizontal projection line across here, and here's your y-coordinate. Now, if this is 4, then what do you think the x-coordinate is here? The y-coordinate, I'm sorry. There's a little x there. You don't want to know how my brain works. Okay, there's a y-coordinate here, right? And you can estimate it. Do you think it's bigger than 4 or less than 4? Of course, it's negative. But you think, okay, where would negative 4 be? Negative 4 would be down here, right? So it's going to be somewhere between 0 and negative 4. You figure out what it ought to be. Okay? And if you think you can estimate it to the nearest tenth, that's okay. It would be ridiculous to try to estimate it to the nearest hundredth, wouldn't it? Okay? But you can draw this picture, you can mark things off, or you can just eyeball it. And of course now, if this is 7, then another 7 would be about out here, so 14 would be here, so what do you think that is? I do recommend you draw a picture of this thing and make your own estimate, okay? But that's how you estimate it. And once you get used to estimating quantities on a graph, because sometimes in a real world situation, that's all you can do. Okay, give it a try, and then we'll see. And then we'll check to see how close your estimate is to an actual point on the line. You're unlikely to get a totally accurate result, okay? But we'll be able to measure pretty easily if you got close. I'll make my own estimates too. And a lot of people in class, when we did this in another class, made better estimates than I did. Okay? And most people made decent estimates. A couple of people kind of missed it, forgot a sign or something like that.